Hello everyone, hope you all are doing well. So in this video we'll discuss the last problem of Leetcode Weekly Contest 349. It's a hard level problem and I would say harder than the other level 4 problems that you get in the contest. You can see that with the accuracy as well. Only 300 solutions accepted out of roughly 5000 solutions. Okay, so yeah, you'll learn a lot of things from this problem. Let's see what the problem is asking us to do, right? So the problem name is maximum sum queries. The problem says that you are given two zero-indexed integer arrays nums1 and nums2, each of length n, and a one index 2D array queries where queries of I is equals to xi comma yi. Now for the ith query, find the maximum value of nums1 of j plus nums2 of j among all the indices j, obviously which lie between 0 to n, where nums1 of j is greater than equals to xi and nums2 of j is greater than equals to yi, or -1 if there is no j satisfying the constraints. Return an array answer where answer of I is the answer to the ith query. Okay, let's see what is trying to say. Okay, so we have two arrays, nums1 and nums2. Both of them have the same length, right? Basically they represent a pair, right? Like the first pair is at 0th index you have 4 and here you have 2. So 4 comma 2 is a pair. Similarly at first index you have 3 and here you have 4. So 3 comma 4 represents a pair. Similarly 1 comma 2 represents a pair. Sorry, 1 comma 9 represents a pair, and then 2 comma 5 represents a pair. These are basically 4 pairs. Okay, let's see what are the queries. So the first query says that consider all the pairs where the first number, right? This is the first number that you have picked from nums1. First number is greater than or equals to 4 and the second number is greater than equals to 1. Okay, just see what are those pairs. So first number greater than equals to 4. This is the only pair, right? Where the first number is greater than equals to 4. So you have only one pair. And for that pair, what is the sum? It is 4 plus 2, that is 6. So for this query, 6 will be your answer, right? Let's consider the second query. It is 1 comma 3. So consider all the pairs where the first number is greater than equals to 1. What are those pairs? This is valid according to x, this is valid according to x, this is valid according to x, and this is also valid according to x. But in those pairs the value of y should be greater than equals to 3. Okay, so now just see, this is not valid, this is valid, this is valid, this is valid. Okay, so 3 valid pairs are there. Now for all these 3 pairs, find the sum, find the corresponding sum and return the maximum among them. So the sum for this is 7, for this is also 7, for this is 10, right? So 7, 7, 10 are the 3 possible valid pairs that you have, rather the sum of the valid pairs that you have. And obviously since the maximum value is 10, so 10 is your answer, right? Similarly the last query says that consider all the pairs where the value of x is greater than equals to 2, right? So this and this. Also the y value should be greater than equals to 5. So now this is invalid, this is invalid, this is the only valid pair. So since you have only valid pair, no need to find the maximum, you just have only one possibility. So 7 is your answer, right? All you need to do is for every query is consider the pairs where the first value is greater than the first value in your query, and the second second number in the pair is basically greater than the second number in the query. That's it. And you have to find the maximum sum for each query, right? Similarly, if I look into the second example, so this is 3 to 5, 2, 4, 3. What are the pairs? 3 and 2, 2 and 3, 5 and 4. These are the 3 pairs. For the first query, it says that x should be greater than equals to 4, y should be greater than equals to 4, right? This is the only valid pair. Answer is 9. X greater than equals to 3, y greater than equals to 2. This and this. These are the 2 valid pairs. Sum of this is 5, sum of this is 9. So 9 is your answer. This one, sum of x should be greater than equals to 1, y should be greater than equals to 1. All the 3 pairs are valid. So sum for this is 5, for this is 5, this is 9. So maximum is 9. 9 is your answer, right? And let's see the last example. So this is 2, 1. What are the pairs, right? This 2 forming a pair. This 1, this 3 forming a pair. So x should be greater than equals to 3, y should be greater than equals to 3. Just see, there are no pairs satisfying your condition, so you return -1. That's it. That's what the problem is asking us to do. Let's see the constraints. The number of elements that you can have in both the arrays. Obviously the number of elements is same. It goes up to 10 raised to power 5. Each value can be 10 raised to power 9. The number of queries that you can have is 10 raised to power 5. Okay, and obviously each query will be of length 2, and this is xi and yi, right? Basic stuff. Okay, now let's simplify this problem. Okay, let's simplify this problem. Right now it is, I would say, a little bit complex. Let's simplify it and see how we can solve it, right? Remove, right now there are two constraints. One is related to x, one is related to y. First, let's solve it with just x constraint. Suppose this is not given, only this is given. Okay, so consider that the problem is asking that find all the pairs which have value x greater than the corresponding value, right? So what I'll do, simplest thing would be, what are my pairs? 4 and 2, right? 4 2 3 4 1 9 and 2 5. These are the pairs that I have, right? These are the pairs. So what I can do, since I only have to search based on the first value, this is x. Okay, suppose your query is just 4, right? What you can do, you can simply sort it, right? Sort the pairs, I mean sort based on x, but keep a track that, okay, 4 is related to 2, 3 is related to 4, 1 is related to 9, and so on. If you sort it, what do you get? You get 1 2 3 4, and 9 is paired with 1, 5 is paired with 2, 4 is paired with 3, 2 is paired with 4, right? These are the pairs. Now if someone asks us that, okay, tell us what's the maximum sum that you can get if your x is greater than equals to 2. Suppose someone says that. So we know that these values are sorted. I can directly do a binary search. I can come to this index, right? That, okay, all the values on the right side of this are valid pairs for me. Okay, so I can just do a simple traversal and find the maximum sum, right? This is what I can do. So binary search to go to the index from where you have all the valid pairs, and then just do a single traversal to find the maximum value. This is one of the possible solutions, right? How you can optimize it? We can simply optimize it using suffix, using the suffix technique. What do I mean by suffix technique? So right now I have 4 values, right? I can basically create an array of 4 where the ith index will store the maximum sum of a pair you can get, right, if you move from the ith index to end of the array. Okay, what do I mean by this? Sum of this pair is 6, this pair is 7, this pair is 7, this pair is 10, right? If I consider all the pairs from in this range, right, that means from the last index, right, this is third index, right, third to the last index, that is the same index. So the maximum sum you can get is 6. What if you consider these two? What's the maximum sum you can get? You can get whatever maximum you have seen till here and the current value. So that is 7. If you consider all the pairs from here to here, right, what can you get? So the maximum value you have got till here and the current value. So maximum of 7, 7. Okay, what is the maximum pair sum you can get if you consider all the elements? So whatever is the maximum sum you have got till here, that is 7, and the current sum, that is 10. So you get 10. So now the problem is simplified, right? How the problem is simplified? Suppose I do it like this. This is 1 2 3 4. That means I take the x values, and with those x values I store the sum of the pairs, right? Now if someone asks me that, okay, tell me the maximum possible pair sum that you can get if your value of x is greater than equals to 2. So what I'll do, I'll do a binary search. I'll come here, and now I know the value I've stored here is 7. That means if I consider all the pairs from this to the end of the array, the maximum sum I can get is 7. I directly return my answer as 7, right? Simple. A binary search would work here. Okay, so this is how we will solve if I only have one constraint. Okay, but and also why I was able to solve it, because I knew that when I have come to this index, all the values on my right side are basically valid pairs for me, right? Because if I say I have to consider all the values which are greater than equals to 2, so now since this is 2 and the array is sorted, I know all the values here will be greater than or equals to 2. So all the values are valid here, right? So that was the main technique, how we were able to solve this question if we had only one constraint. But here we have two constraints, right? One is based on x and one is also based on y. So if we sort our array, right, if we sort our array, what did we do? 1 2 3 4. Okay, with 1 we had 9, this was 5, this was 4, and this was 2. These were the pairs, right? If we do a binary search and come to 2, that okay, all the pairs which have x greater than equals to 2 are here, but if I also have another constraint that among these pair you also have to consider the value of y, then the problem becomes complex, right? then we have to see how we can solve this problem, right? And that is the trick here, how we solve these type of problems, right? So consider these things, right? I have these values as in sorted format. I know the x is valid. I know x is valid in this range, right? I only need to keep a track of y. So another option is, I know the values of x are valid. Can I sort this part? Can I sort it? Can I do 2, 4, 5, right? If I can do it, obviously the complexity will increase. But if I can do it, then I know that, okay, all the values here are greater than equals to 2. Now if someone says that the value of y should be greater than equals to 4, I can do a binary search. I can come here. So I know all the values in this range are valid for me, right? This will make the problem simpler, right? This is already sorted. I know these are valid values, but for the lower values, they are jumbled. If I get them in sorted format, I can solve this problem, right? This is the main trick. But obviously that will increase the complexity. So what we can do? Okay, what we can do? So another approach here is, right, just see what the problem is asking us to do. It is saying that return an array answer where answer of I is the answer to the ith query. These are the queries that you have, right? These are the type of queries you have, right? So why not we process the queries such that, right? Why not we process the queries such that we only have at a particular point of time all the values, all the pairs which are valid for me based on a particular value, right? For example, if I say this, if I sort this, right? Suppose I sort this. So I get, obviously I have to keep the track of indices as well, right? So this is index 0, this is 1, this is 2. The first pair is 1, 3. Second pair is 2, 5. Third pair is 4, 1, right? What I mean to say is, if I somehow have to process, suppose I process this, right? 4, 1, right? So I know that if I have processed this value where the value of x was 4, right? Where the value of x was 4. Okay. Now after this, if I process this pair, right? Now here the value of x is 2. So till now, what are the values that I have processed? These two values, right? These two values. So all the values, right? All the values which are greater than equals to 4 are obviously greater than equals to 2, right? Right? Are obviously greater than equals to 2. Why am I doing it? Because I have two values to consider here, is x and y. Okay. I can sort only one of them, otherwise the complexity will increase. So instead of sorting x, what I do, I process x such that all the values of x that I have processed are in my valid, are valid for me, right? Are valid for me. How do I do that? I do that by processing the queries in decreasing order of x values. In decreasing order of x values. Like in this case, first I'll try to process pair 4, 1. Okay. So if I process pair 4, 1, so what I'll do? I'll go to this array. Okay, I'll go to this array. Obviously, I'll sort these pairs as well, right? In sorted format, these will look like this: 1, 2, 3, 4. Sorry, the pairs were like this, right? And let me write the pair values. So the pair values are, yes, 1, 2, 3, 4, and with 4, what do I have? This 2, this is 4, this is 5, this is 9, right? These are the pairs, right? Now I have to process. Suppose this query 4, 1. This is the first query I'll process because this has the maximum x. I go in my array and what I do, this is sorted. I start processing it from the right hand side. I put this in my valid space. So it is 4, 2. This is my valid pair till now. Okay. Now the next pair I get is 3, 4. Obviously 3, 4 is not valid because I have to consider all the values where x is greater than equals to 4. Okay. This is the only valid pair. Now here, right now I have only one pair, but what I can do, I know that all the x values are valid for me. Now based on y values, I can keep them in a sorted format, right? I can keep them in a sorted format. How I'll do that? That I'll show in the implementation, but the main logic is this, right? Now the next pair that I'll process is 2, 5, right? So this was already in my valid set. I've already put it. I'll go here, right? The next pair. I'm going in the reverse direction, right? Consider all the x values which are greater than equals to 2, right? So here the value of x is greater than equals to 2, it is 3, right? So 3, 4 is also a valid pair, and here 2, 5 is also a valid pair. Okay. So just see now, because you are processing the queries in order, all the three pairs are valid based on your x values, right? Now you only have to keep the y values in sorted format. So what are the y values? It is 2, 4 and 5. Okay. So keep them in sorted format. Use any data structure. I have used a tree map. Okay. I have used a tree map. So based on this, we can do it, right? Now the next query that I'll process is 1,3. So I'll come here, okay? Because I have added the values in my valid set till here. I'll come here, and what I'll do, I'll add this, okay? So now the last pair that I add is 1,9, okay? So 1,9 is also added. So I add 9 here. So y values are sorted and all the x values are basically valid for me. So this is the main logic how I will solve this question. Now the implementation will can vary based on what you use, right? So now comes the question, what do I do after I sort the y values, right? Now comes the question, what do I do after I sort the y values? So here what we will do, just see this is the last part. Since this is a good question, right? So we have a solution in multiple parts, right? So what we'll do, let me change it. Let me come here. Let me do it like this, okay? Probably on a new page, it will be better to explain, right? So my pairs were 1, 2, 3, 4. This was 2, 4, 5 and 9, right? Now, when I have these values are sorted, the first pair I put is 4, 2. So I have 2 in my 4 is valid, right? So forget about 4. These are the y values I'm considering, right? So for 2, what is the sum of this pair? It is 2, 6, right? Now the next pair that I process is 3, 4, right? So 3 is also valid. I come to 4, right? And it is 4 and 7. It is 4 and 7. Now, when I add this into my data structure, what I'll do? Just see this. I am going to add key number 4. Remember, the key is the y value and the value for that particular key is the sum, right? When I'm going to add 4, the sum of 4, right? Sum of 4 is 7, which is greater than the already added sum. So that means I can blindly remove it. Why I can remove it? Because any number which is greater than equals to 4, right? Any number which is greater than equals to 4 is obviously greater than or equals to 2, right? Right? This is what will happen. Presence of this pair before this pair means that this pair had a greater x value but a smaller y value. Getting it? Now I have got a pair with a lesser x value and a greater y value, right? So what I'll do here, I'll add it. Addition of a new pair in my data structure, what it does is, since I'm keeping the y values in sorted order, it can do two things. Suppose that I have a pair 2, 6, 4, 7, and suppose this is 8, 10, something like this, right? So what would happen? So the first thing that I added was 2, 6. Okay, this is only a single pair. Remember, this is y value and this is the sum. Okay. Now suppose the next value that I add is 8, 10. So when I add 8, 10, that means the value of y is 8 and this is the sum, right? So this means that for all the values, for all the pairs greater than equals to 8, where y is greater than equals to 8, I have a sum of 10, right? There is a pair where y is greater than equals to 8, or rather y is equals to 8 and the sum is 10. So obviously for the values less than 8, where the values of y is less than 8, if the sum is less, right? Here the sum is 10, here the sum is 6. I don't need it, right? I don't need it. I can blindly remove it. Suppose there is another pair 3, 5, something like this. Suppose there is 3, 5. So these keys are smaller than 8. Okay. Now if someone says that consider all the pairs which are greater than equals to 5, greater than equals to 1, whatever you call it. So just see here, I already have 8, right? Here I already have 8. Forget about this. Here I already have 8. So any value greater than equals to 8 will obviously be greater than equals to 3. So you just remove it. Keep on removing it till your current sum is greater than the already added sum, right? Why we are doing it, I've already explained you, right? This is what we do. Another possibility here is you are adding 8, 10. However, there is already a pair, suppose 12, 20 present, meaning the y values are also greater than this and the sum is also greater than this, right? So now what you will do? Now what you will do? You simply add it. You will simply add it because there is a possibility that between these values, between these y values, I can get a query where y lies between these values, right? This tells that when y is equals to 12, you get a sum of 8. This tells that when y is equals to 8, you get a sum of 10. But what if someone asks that, okay, tell me what is the value what is the sum of pair when y is greater than equals to 9 or something like that, right? So you need to keep a track of middle values as well, getting it? So that's why whenever you get a value, try to what you do, try to update the entries which are present before where this is added, right? Because we are trying to maintain a sort of increasing order in your data structure. You can consider it as a monotonic stack or something like that, right? In short, the logic here is keep the values of y and the sum such that when I do a search, I can directly get the values there, right? These values are of no use, because if I have a pair with where the value of y is 8 and sum is 10, why do I need a pair with where value of y is 3 and sum is 5? I don't need it, right? Because any query that I get, this guy can tackle it, right? This guy can obviously tackle it. Getting it? So that is why we can keep on removing it, right? Because suppose someone says that, okay, tell me the maximum sum that you can obtain if the value of y is 2. So what are the valid pairs? 3, 5. Rather, you can consider y is equals to 3 and you can also consider y equals to 8. But obviously this is a larger sum, you just consider it, right? So that is why we do it like this. So let's come to the implementation part. Seeing the implementation, it will make it more clear, right? These are the number of elements that I have. These are the queries, right? Now, these are the pairs I form, right? Nums1 and nums2. And I sort them. Remember, sorting them, sorting the pairs in the in increasing order of x values, so that I can keep a track of all the valid x values, right? I can process my queries in reverse order. I'll show you that, okay? I'll show you that. So I sort it in increasing order of x values. Now what I'll do, I'll sort the queries in decreasing order, okay? Because what did I say? We'll process the queries such that the query having the maximum x value is processed first, so that I only consider the pairs which are valid at every particular point of time, right? Because if I have processed all the pairs where the requirement was that x is greater than equals to 10, and next time I process all the pairs where x is greater than equals to 2, so these pairs are actually a subset of these pairs, right? So that is why we are adding it, so that whatever entries we have, those are valid for us, okay? That's what I do. Add the indices in basically an array and just sort it, right? This is a good technique to sort, that these are the queries and these are the indices, so you just sort them, okay? Simple. In decreasing order. This is increasing, this is decreasing, okay? Now I create a tree map. Why I create a tree map? Because in tree map the keys are sorted. Remember what did I say? That I'll process the queries such that I have valid x values, and for the y values I can keep them in sorted format. So tree map basically keeps the keys in sorted format. So just see nums2 to sum. This is the map I have. Key will be nums2 wala the y value of the pair and corresponding sum, that is x plus y, okay? This is the answer that I have. J starts from n-1 because the pairs are sorted in increasing order. So the last pair will have the maximum x values, and I'm processing the queries with the maximum x values. So that is why I'll do that, right? I'll do a dry run, don't worry. So these are the indices. This is the first query, or rather these are the queries that I process. This is the x value requirement and this is the y value requirement, right? Now while j is greater than equals to 0 and pairs dot get of j of 0 is greater than equals to x. What does this mean, right? So if I consider the first case, okay, so in first case these were my pairs, right? 1 2 3 4, and this was 2 4 5 and 9. So I have sorted my pairs like this, and I have sorted my queries like this. Queries are 4 1 2 5 and 1 3. So this is how my queries array look like, and this is how my pairs look like, okay? So j is equal to n-1. That means start from here. In this direction, start processing, considering your pairs. And which query do you process? First, you process this query having the maximum x value, okay? So that is why j is equal to n-1, okay? This is x, this is y. This is x, this is y. While j is greater than 0, that means start processing from here and move till the x value is greater than what you need in your query, okay? What you need in your query. So while j is greater than equals to 0, pairs dot get of j of 0. That means pairs dot get of g of 0. That means this is the jth value and 0th value means this is an array, right? So 0th value is x value, first value is the y value. So while the first value is greater than what you need, you keep on adding it. How do you add it? Just see. For this pair, the y value is 2. Current pair sum is 4 plus 2, that is 6. Call a function update. Pass the tree map. Pass the value which will act as a key for that particular map, and pass the sum which will act as a value for that particular map, right? Do j minus minus. Because now I'll move here. I'll see that is this 3 greater than or equals to 4. Okay. If this is not, you just break the loop. And now you go to the next query. And for that query, the next query is this, right? 2, 5. So now you'll continue from here. This 3 is greater than this 2. So you again update your map. Then you move here. This 2 is again greater than equals to this 2. Again add that in your map. Getting it? Now you call this function. Now what this function does, I'll show you. But ultimately you call this function and you break the loop. Again you go here, you process the last query. Last query is this. Here the requirement is greater than equals to 1. So you go here, right? You are already here. You already added the pairs in your map till here. You come here now, you do j minus minus, right? You come here. This 1 is greater than equals to 1. Add this as well, right? And by calling this function, and finally you get your answer for each query by calling this, right? Now let's see what this update function is doing. In my update, I'm passing the tree map, the y value and the corresponding sum, right? Let's come here. Okay. Yeah, this is it. So this is my map. This is the y value and this is the sum. So what did I say? The first step is I'll check that, okay, give me the entry, floor entry, give me the entry where the y value is less than or equals to the current value. Getting it? What do I mean by this? Suppose the value of y that I was having in my map is 8 and 10. Okay. And now the value that I've got here is the value of is suppose 7 and 20, something like this, 6 and 10. Suppose I get values like this, right? So this was there in my map. This was there in my map. Let's make it 9. And suppose I add 7, 10, right? That the current value is 7 and 10. So what do I say? I say that return me the smallest key which is less than or equals to 7. So this is the smallest key, right? This is the smallest key. What I'll do, I'll check that here it says that for a pair with y value as 6, the sum was 10. But I already have a y value with 7 and the sum is 20. So why do I need to keep it? I don't need to keep it, right? Because for any pair, right? For any pair where this is valid, right? This acts as a subset for this, right? So let's do that. This is the entry that I have. Okay. While entry is not equals to null, entry.get value is less than equals to sum, right? Check this. If the sum for this is less than equals to 20, so what do? You remove it. You remove it and you keep on moving back. You keep on moving back. How do you move that? Next smaller key is obviously entry.get key, right? What do I mean by this? I found this key as the lower, by floor entry. Now I'll do a floor entry for this. I'll find the previous key. Again, I'll do the floor entry using this value. I'll find this. I'll do a floor entry using this key. I'll find this value, right? I keep on doing this till I've either consumed all the values or the sum for this particular value is not less than equals to sum. Rather, that is greater than equals to sum. Like for example, if there is a pair 3, 100, okay, then I'll stop. Okay, then I'll stop. I'll basically stop, right? Okay, this is what this particular loop is doing. Getting it? This is how I'll do. Now, entry equals to nums2 dot ceiling entry dot sum. What do I mean by ceiling entry? Ceiling entry is just opposite of floor entry. That if I do ceiling entry of 720, rather 7, it says that return me the smallest value which is equals to or greater than 7. So that will return me 8. Okay, that may return me a. If that entry is null or that entry.get value is less than sum. Okay, so what I'll do, I'll put this value. I'll put this value. What does this means? Suppose here I have 8 and 9. So I will put this value because 20 is greater than 9. However, if I would have had 80 and 90, then I would have not put it, right? I would have not added this in my map because of the same reason. Because 8 and 90, right? For a larger key, I already have a larger sum. Why should I add a smaller key with a smaller sum, right? So that is why if entry equals to null or the value that you are getting is less than equals to sum, then only you add it. Otherwise you do not add it, right? Why am I doing all these things? Because whatever values are valid for this, right, are actually for valid for 7 as well, right? If I say return me all the pairs which are greater than equals to 8, so these pairs are valid for greater than equals to 2 also. So that is why I'm removing these smaller keys if they have a lesser sum, right? If they have lesser sum, because 8 comma 90 and 2 comma 50, what does this means? That I added a pair which had y value is 20 and the sum was 50, but now I have a pair where y value is 8 and the sum is 90. So if someone queries that, okay, consider all the pairs where y is greater than equals to 2, so why should I consider this pair? I will directly consider this pair, right? Because these both are valid, right? These both are valid. This is even a larger value, so I'll consider the maximum sum. So no need to keep it, no need to keep it. Getting it? That is why. Now you must be wondering, what if someone asks that consider a value greater than equals to 4? Again, this guy is considering it, right? This guy is considering it. Everything will be considered, right? So that is how we keep a map which is sort of monotonic, increasing map, right? Where we have something like this, that the keys are increasing and the sum is decreasing. Getting it? 100, 50, 20, something like this. 2, 5, 10, right? Keys are increasing and the sum is decreasing. Okay. Now, what is the answer for each query? Just see, after the while loop is over, you call this answer equals to get max sum, pass the map and the y value, because x values are already valid for me, right? I have only considered the pairs which are valid for me. X value is valid for me. Okay. Again, come here, map dot ceiling entry. Okay. Whatever is the y value, consider the smallest value which is greater than equals to this y value. What do I mean by this? Suppose I have to consider that y value should be greater than equals to 8, but in my map the largest key that I have is 2, so that means I do not have a pair, right? So that is why map dot ceiling entry. However, if I have a 10, then yes, I have a valid pair. Okay. So if entry equals to null, that means the y value for which you are searching, if that is the largest value, so your entry will be equals to null, you return -1, or else you just return the sum that you are having, because we are already storing the maximum sum. Getting it? And finally, you are doing it for all the indices, and finally you return the answer. If you want, I can do a dry run for this one. The dry run will look something like this, that I start processing from here. The first query I process is 4,1. So my map will look like this. This is the x value. The first query is this, right? I put my map, and in that map I'll have 4 and the sum will be 6. Okay. So the answer for the first pair will be 6. Just see, it will be 6. Why it will be 6? Because this is the only entry in my map. Now when I go here, get max value, I call that, okay, return me sorry, this will be 1. I add the y value, right? Here the y value is 2. This is the x value, this is the y value. Okay. These are the thresholds, basically. These are the queries. So for 2 I have 6. Now for this query I'll call that consider all the pairs where y value is greater than equals to 1. So I directly call my map and I get this entry and I return 6 as my answer. Okay. Now I move to the next query. For this next query, I'll consider all the pairs where x is greater than equals to 2. So I consider this pair. So this is 3, 4. Okay. Y value is 4 and the sum is 7. I go here, y value is 4, sum is 7. Okay. The first thing that I do is find the first entry which is less than equals to 4. That is 2, 6. Here the sum is equals to 6, which is less than my current sum. I'll remove it. The only entry I'll have in my map is 4, 7. Okay. The next entry that I'll add here is, remember, to process this query, first I'll add all the entries, right, which are valid. It is 2, 5. Okay. So what I'll pass 5, 7. Right. I'll pass 5, 7. So first, when I pass it in my update function, the first thing I'll do is, okay, check the first value which is less than or equals to this 5. This is 4. and the sum here is actually equals to both of them have equal sum. Again, I do not need it. Had the sum here been 17, I would have kept it, but now I can remove it, right? Because all the values that are being covered here are already covered here, right? Getting it? Whatever is my answer for this, that is basically that covers this, right? So I removed this as well. Now I'll not add it, right? I move to the query. I call my get max. I say that tell me what is the y value which is basically greater than equals to 5, this, and here hence your answer will be 7. Just see, your answer is 7. Getting it? Your answer is 7. Remember, this is query number 1, this was query number 3, this is query number 2. Getting it? So remember, the indices matter a lot, index number I. Okay, now for the last index, what I'll do, I'll just add this entry as well, that is 1 comma 9. So 9 comma 10 will go in my map. So 9 comma 10, what is the smallest value, what is the value less than this? It is 5 comma 7, right? These are the only two entries in my map, right? Now again, 5 is less, 7 is less, remove it. 9 comma 10 is the only entry that you will have in your map. Now again, call this query that okay, y value should be greater than equals to 3. This is the only value that will be returned, and 10 will be your answer. Getting it? So this is how the thing works. Look, this is a very good question, and it involves a number of concepts. So if you have not understood in the first go, I would highly suggest it using a pen and paper, and writing the logic that we have just discussed. It will become clear as to why we are doing each and every step, right? Why we are sorting something is in increasing order and something in decreasing order, and why we are maintaining a monostatic map, right? Monotonic map, that okay, these values are increasing. Okay, so I'm keeping the keys in increasing order and values in decreasing order. Why we are doing all these things? A small pen and paper would work in this case, right? But still, in case you feel that something is not clear and you still have some queries, mention that in the comment section. I'll revert on each one of them, right? I hope this video was fruitful, right? So let me know what you feel about this video. Also, as I said, in case of any queries, please add that in the comment section. I'll try to resolve each one of them. It will be hard to explain these things in comments, but yeah, I'll try my best. Okay, so yeah, thank you, take care, bye bye.